Okay, so 6-3 is all about simplifying these radicals. So it's looking at the root and asking ourselves, is there anything that we can take out of underneath this root and move to the outside? So just bear with me, I'll show you what I mean. If I have the square root of 25, well, it's a square root, okay? So that basically means we're looking for two items. So square root, we're looking for two items that are the same, that give me 25. And we know that the square root of 25 is 5. But why is it 5? It's 5 because what I am essentially doing here is I'm saying the square root of the number 25 times what is 25? So I have 5 times 5, right? Now, this is a square root. How many 5s are there? 2 for the root, 2 for the number of 5s. So for every pair, every two items, I can move it to the outside. So the square root of 25 is really the square root of 5 times 5, but that's a pair, so I move it to the outside. Well, there's nothing left in the inside, so I don't need to include it. Okay, so let's do another example, but let's leave something inside. So how about the square root of 50? Okay, the square root of 50, I need to break down 50 into its smallest pieces so I know what the pairs are. 50 is 5 times 10, and 10 is 5 times 2. Okay, so I'm going to take this thing and put it underneath the radical like this. 5 times 5 times 2, right? Because 5 times 5 times 2 is 50, so I haven't changed the inside. I've just rewritten it in a different way. And so now I'm looking for pairs. Why? Square root. Square root tells me pairs. I have a pair of 5s, but what's left? The 2. So I'm going to take the pair of 5s outside, but I'm going to leave the 2 inside. And that's it. So all we're doing when we're talking about simplifying is we're identifying the root first. The root is square. How many pieces do I need to have that are the same? 2. Okay, so if the root is square, we got to take out 2 pieces. If the root is a cube root, how many pieces do I have to take out then? I've got to take 3 pieces out. I have to find 3 things in common that I can move to the outside. So if I have something like the cube root of 27, okay, well, I'm going to write 27 is what? 3 times 9? And 9 is 3 times 3? So 3 times 3 times 3 is 27. So I'm going to rewrite the inside. 3 times 3 times 3. Now what are we looking for? You remember? We're looking for groups of 3. Why? Because it's a cube root. Groups of 3 for a cube root. So, is there any groups of 3? Why, yes there is. There's one group of 3 3s. Whew. So, what does that mean? It means it can move to the outside. Now, is there anything left inside? No. So there's nothing else left. Okay? But what if we had an example where something was left inside? For example, I don't know, the cube root of 24x. Oh, I added an x this time. Okay, so we have to think. First, always just one step at a time. So we're going to forget about the x for now and look at the 24. 24, and you're saying to yourself, 24, that's 2 times 12, or 4 times 6, or 3 times 8. All of those are valid, but what we want to do is we want to pick one of them and then break it down as far as it will go, like I did here. I did 3 times 9, but then I took the 9 and broke it apart. So if you want to do, I'm going to do 4 and 6. Okay, now they both can be broken down. 4 is really 2 times 2. 6 is really 2 times 3. Now, I'm simply going to take this. I'm simply going to take this thing that I have now, and I'm going to replace the 24 with that thing. The cube root. 2 times 2 times 2 times 3, but can't forget the x. Now, it's a cube root, so what are we looking for? Groups of 3. We're looking for groups of 3. So, there's a group of 3. That means it can move to the outside. So, 2. Cube root. Now, make sure the root stays cubed. Don't forget to include the root. Now, do 3 and x have groups of 3? No, they don't. So we have to keep them inside. 3x. And that's it. So let's do one more example with maybe like a fourth root. Okay, maybe like a fourth root, and I'll throw in some variables. But remember, variables don't make things complicated. Variables are actually easier whenever we're talking about this than numbers. And I'll show you why with this example. So we have the fourth root of, let me think of a number while I'm writing these other ones down. Okay, so I think I've figured out a number. We'll go with 48. Okay, so I like to focus on the numbers first, so because it's often the hardest piece. So let's look at 48. Now, if you don't remember what 48 is, that's fine. It's even. So remember, any even number you can always break down by 2. So that would be 2 and 24. Well, 24 is also even, and if I didn't remember the factors of 24, I just know, hey, it's even, so it's got a 2. So I can do 2 times, 12. And then 12 is 2, it's also even, so 2 times 6. And 6 is also even, 2 times 3. Okay, so we're looking at this piece here. You notice I took all the pieces that didn't have branches. Okay, you have to break it all the way down. Those are the pieces we want. So we have the fourth root of 2, 2, 2, 2, 3. 2, 2, 2, 2, 3. Then I still have these 3 pieces, so I got to include those. X6, Y10, Z4. Now, I'm looking for groups of 4. Groups of 4. So I have one group of 4 here in the 2's. So that moves outside. Now I'm just going to, no, that may be not close enough. So I'm going to put the fourth root over here. Okay, now, is there a group of 4 of the 3's? No, there's just one 3, so it has to stay inside. Now, if there is x to the 6th power, what does that mean, 6th power? It means x times x times x times x times x times x. How many times? It means x times itself 6 times. Well, is there any groups of 4 out in 6? Yeah, there's one group of 4 in 6 right there. Okay, so because there's one group of 4, one x moves outside. How many x's are left? 2, so x to the 2. So x squared. So because there are 6, 4, 1 moves outside because of fourth root. 2 stay in. What's 4 plus 2? 6. Okay? Now, with y's, there are 10 y's. Y to the 10th power means y times y all the way till y times itself 10 times. How many groups of 4 go into 10? 2 groups of 4, right? Y to the 2nd. Why? Because one group of 4 is 4 y's, a second group of 4 is 8 y's, and a third group of 4 would be 12 y's, but we don't have 12 y's. we have 10 y's. So if we have 10 y's, I can only make 2 groups out of 10 that are 4 sides, and then how many are left over? Y squared. Why 2? Because 2 times 4 is 8. 8 plus 2 is 10. So another way to look at this is you could say this number divided by this number. Ooh, 10 divided by 4 is 2 with a remainder of 2. Okay, if we're following that logic then, 4 divided by 4 is 1. Is there a remainder? No. So there's no z inside. Now let's backtrack. 6 divided by 4, 1 with a remainder of 2. Okay, so you can always take the powers and divide to get these pieces. Remember, the outside pieces are the whole number, the inside pieces are the remainder. Okay, so you can go back and maybe you have to go back and replay that. If you have any questions, once again, you can join the Zoom at 7. So, that's really it for simplifying radical expressions.